Okay, let's solve a system of equations by elimination. Remember, we're going to combine both scales onto one scale. We're going to add in hopes that a variable will eliminate. So 2x plus 3x gives us a total of 5x. A positive y plus a negative y, those are opposites, so when they add, that's 0. It's been eliminated. And then 10 plus a negative 5 is 5. Now continue solving. Divide by 5, divide by 5. So x equals 1. Now, if x equals 1, we know we have one solution. Otherwise, we'd get something like 1 equals 1, which would be infinitely many, because that's a true statement. Or we'd get 1 equals 4, which is a false statement, so there'd be no solution. So that means we need to continue, because we are going to have two lines that intersect at one point. They have one point in common, and that point of intersection will be 1 something. We're missing the y value. We don't know. So we need to go back to one of our original equations. Your choice, whichever one makes you happy. I like this one because it's all positives. So I'm going to do 2 times x plus y equals 10. But now, instead of x, notice I left those big open parentheses because I actually know the value of x. I just solved and found that x is actually 1. So I'm going to make that substitution so I can solve. 2 times 1 is 2 plus y equals 10. And so now we need to subtract 2, which tells us that y has to equal 8. The point of intersection is 1, 8. Okay, let's look at example 2. Well, notice on example 2 that when we add our two equations, neither of our variables are eliminated. We would still have a total of 3x and a total of negative 3y. Neither one of our variables eliminated, and that's a problem. That's our whole goal with this method, and so we need to make that happen. What would it take? If only this x had a coefficient of negative 2. Then it would be the opposite of this 2x in my second equation. And when I add, they would eliminate. Now I can make that happen if I multiply the entire equation by negative 2. Okay, so let's rewrite that first equation as negative 2x plus 2y equals negative 2. It will still graph to be the same line with the same slope and y-intercept, so that's legal, as long as we're talking about the same line. And we'll leave our second equation as is, not making any changes there. And now we will add to eliminate. And because my x's are opposite, negative 2x plus 2x equals 0, that's eliminated. Continue adding. 2y plus a negative 2y is also 0. So both variables have eliminated, and my left side has no weight whatsoever. So 0 equals negative 2 plus 2 is also 0. So is my scale balanced? Does 0 equal 0? Always. And so that means that we have infinitely many solutions. We can come up with any combination on this line because these are actually coinciding lines. They have every point in common. So any point on the line would be a solution because it's common to both and keeps both scales balanced. And there are infinitely many points on a line. Okay, let's try the last one. Example 3. 2x plus 3y equals 6. Negative 4x minus 6y equals 12. Again, when we go to add, we'll notice that neither of our variables eliminate. We have a total of negative 2x and a total of negative 3y. And so that's not going to work for us. We need to come up with something that will eliminate. If only this 2x were a 4x instead, then it would be the opposite of my negative 4x, and when I add, it would eliminate. And so if I want this to be a 4x, it's already a 2x, so I just need to multiply by 2, and I can do that as long as I do that across the entire equation. I've got to double every term. So 4x plus 6y is equal to 12. Okay, and we'll leave our second equation as is, no changes necessary. Negative 4x minus 6y equals 12. Now, you might run into a situation where you need to alter both equations and multiply through by different numbers, and that's fine. You can do that. Okay, now let's add to eliminate. 4x and negative 4x is 0, so that's out. 6y and a negative 6y is also 0. That's out. And so 0 equals 12 plus 12 is a total of 24. Is that scale balanced? Does 0 equal 24? No, that's not equal. That's false. And so that tells me that we have no solution. These two lines are parallel. They have the same y-intercept, but they have different y-intercepts, but the same slope. And so they're parallel. They're never, ever going to cross. They have no points in common because it's impossible to keep these two equations balanced. So no solution.